Every day, millions of tons of food waste are sent to landfills to rot. But if you introduce a colony of larvae to a decaying apple, that organic waste is consumed in a matter of days, leaving behind clean compost and a dense supply of edible protein. Our current agricultural system requires massive tracts of arable land and millions of gallons of water to sustain traditional livestock, while at the exact same time, our global landfills emit massive amounts of methane from rotting garbage. This dual crisis is why agricultural engineers are turning to six-legged livestock. These biological organisms offer a targeted solution capable of processing our food waste and producing protein without the heavy land and water requirements of cattle or pigs. This line chart shows the exponential market growth projection of the edible insect industry. While traditional agriculture remains relatively flat, the insect market is expected to reach £7.8 billion by 2030, driven by a reliable 24. It is shredded and ground to achieve an exact moisture optimization of 50 to 70%, ensuring the material is easily digestible for the colony. The breeding reactor itself operates under rigid environmental controls. To maximize egg-laying and larval development, the facility maintains a non-negotiable temperature baseline of 25 to 30 degrees Celsius, paired with 60 to 70% humidity. This comparative bar chart shows the disparity in feed conversion efficiency. Feed conversion efficiency is a metric that measures the amount of raw feed input required to produce a single unit of animal mass. Because they are cold-blooded, insect colonies convert raw organic mass into usable meat exponentially faster and with far less feed than mammals. The nutritional output of this rapid life cycle is incredibly dense. Depending on the exact species and diet, dried insects yield up to 69% pure protein by weight, along with high concentrations of omega-3 fatty acids. And just as these colonies can rapidly double their biological mass under the right conditions, you can help us quickly grow this channel by hitting the like and subscribe buttons below. The industrial value of this phase lies in the microscopic efficiency of taking zero-value organic waste and upcycling it into high-density biological assets. Once the larvae reach physical maturity, they enter the mechanical harvesting phase. Using automated separation systems, the mature insects are physically sifted and removed from their residual growing substrate. To ensure the safety of the downstream products, the facility deploys a mandatory HACCP killing step. HACCP, which stands for Hazard Analysis and Critical Control Points, is an international system for reducing safety risks in food. Here, thermal heating or flash freezing is used to completely eliminate pathogens. Following the kill step, the raw insect biomass is dehydrated in industrial ovens or freeze dryers. The dried material is then milled into a fine, shelf-stable, high-protein meal. Beyond the protein powder, the facilities also run a secondary extraction process. The larvae are pressed to extract high-value essential oils, which are rich in fatty acids and utilized extensively in commercial livestock feed. The system even monetizes the waste. The leftover insect manure, a byproduct known as Frass, is captured, sieved, and sold commercially as a premium, nitrogen-rich organic fertilizer. By utilizing the oil, the protein, and the waste, this factory model operates as a perfect closed loop. Every single biological output generates an independent, highly profitable revenue stream. The industry currently operates on two distinct scales. The first is the specialization model, where smaller, agile farmers focus entirely on a single step, like breeding live insects to supply local pet shops and bait markets. The alternative is the vertical integration model. This is where massive, centralized operations completely control the supply chain, managing everything from the initial waste collection to the final distribution of milled proteins and oils. But regardless of the model, the industry faces a specific friction point: the deep psychological disgust many Western consumers feel toward the idea of eating whole bugs. The industry bypasses this consumer friction entirely by relying on strict European Union safety regulations. These legal frameworks allow insect biomass to be processed invisibly into ingredients for animal and aquaculture feeds. The industry's multi-billion-dollar endgame focuses on replacing the millions of tons of water-intensive fish meal and soy currently used to feed global livestock. When viewed through this lens, the common household pest takes on a different profile. It is a highly efficient, perfectly engineered biological micromachine, naturally optimized to process the exact organic waste we throw away. Insect farming merges stark biological reality with pure industrial efficiency. By applying factory logistics to the life cycle of a larva, it offers a scalable, sustainable engine capable of securing the global food chain.